One note from example number 4 that I did not think to share with you is you may not cancel these secant squared thetas. The reason you cannot is because in the numerator they are held together with subtraction. Had they been bound by multiplication, then yes, they would cancel. But this one is bound in the numerator with a subtraction sign. So you may not cancel the secant squares. All right. This is example number 5 in your text. Your author decided to work on the left-hand side. I'm choosing to work on the right-hand side. So you are not bound to work these the same way. If you are working with a friend at home doing your homework in some manner, then it would make sense to work them the same way. So I'm going to choose to work on the right-hand side, and I want my answer to end up like this. And again, your author worked on this side, and he made his left side look like the right. I'm going to make the right side look like the left. All right. I'm going to multiply the numerator and denominator by the conjugate of the denominator. This is strictly algebraic. It is definitely allowable. Okay. In the numerator, I could distribute and do cosine x times both of these terms, but I'm going to just write them out as they appear. These are two separate factors, the factor of cosine x and the factor of 1 plus sine x. And in the denominator, I'm going to get 1 minus sine squared x. This is FOILed. This is the difference of squares. A minus b times a plus b, or a squared minus b squared. I do know that in the denominator, this is the same as cosine squared x. This is the Pythagorean identity. And in the numerator, I have a cosine x times the quantity, 1 plus sine x. And notice I have not distributed those yet because I think it's going to be helpful to not. Matter of fact, here's where it comes into play. This cosine x is going to eliminate with one of them downstairs. That's going to leave you upstairs in the numerator, 1 plus sine x, over a singular cosine x. Then, as we did in example number 4, I'm going to split the numerator and put them both over the denominator. And 1 over cosine is secant x, and sine over cosine is tangent x. And that is what we're asked to verify, that these two things are indeed the same. And I believe we've shown that they are. Now, this is not the way the author chose. He chose to work on the left-hand side. You're definitely welcome to go back and look at example number 5. It probably is no more steps or no less steps. He just did it a little different method. Thanks. Hope you enjoy this.